Chapter 1 Review, Section 1.1 Solving Equations. Our first step will be to clear the equation of fractions if needed. Step 2, simplify both sides of the equation. Step 3, get all terms with the variable on one side of the equation and all terms without a variable on the other side. Step 4, isolate the variable. So let's work out some example problems. In our first example here, we don't have fractions. We're working to get x equals. Let's start by simplifying the left and right hand side by combining like terms. On the left, we have two x terms. 6x minus 7x is minus x. And we still have plus 5. On the right hand side, we have the 10 and the plus 3. Those are like terms, so when we combine them, we'll have 13, and we still have minus 4x. So now we want to get all the x terms on one side together. I usually do that by eliminating the smaller of the two x terms, which is minus 4x in this case. The opposite of minus 4x is plus 4x. If we combine those two, we'll get 0, so the x's will be eliminated from the right-hand side. If we add 4x to the left-hand side, we'll have 3x. We still have the plus 5 equals 13. On the left-hand side, we now want to eliminate the plus 5 term so that the 3x will be by itself. The opposite of plus 5 is minus 5. So we're going to subtract 5 from both sides to keep the equation in balance. 3x equals 8. Now we want to eliminate the 3. It's 3 times x. The opposite of multiplication is division. So we're going to divide both sides by 3, which gives us x equals 8/3. And that is our solution. We can substitute this solution back into the original equation in 1, 2, 3 places in place of x. And then work out the left-hand side, work out the right-hand side, and you will get a true statement. It's always a good idea to check your solutions. So now we have another problem, and we have parentheses. We eliminate parentheses using the distributive property. So 2 minus 5x, be very careful, because it's minus 5 times a plus 5, which is minus 25. You want to make sure when you use that distributive property to realize that that negative is applying to the second term as well as the first. So eliminating the parentheses on the right-hand side, we have 3x minus 6 minus 1. Now we combine like terms. On the left-hand side, we have 2 minus 25, so it's minus 23 minus 5x. On the right-hand side, we have like terms, minus 6 minus 1, so we have 3x minus 7. Now, I like to eliminate the smaller of the two x terms, so I'm going to add 5x to both sides. Whatever I do to the left, I must do to the right to keep the equation in balance. I still have a negative 23 on the left. I now have 8x minus 7. I need to isolate that x term. The opposite of minus 7 is plus 7. So I'm going to add 7 to both sides, and that gives me negative 16 equals 8x. I need to isolate. I need to isolate the x. I need to get rid of that 8 times. I do that by dividing both sides by 8, and that gives me the solution x equals negative 2. You can write negative 2 equals x or x equals negative 2, either way. So that is our solution. And as always, it's a good idea to write that solution, put that solution in the original equation and check and make sure it is correct. Our third example, we're going to eliminate the parentheses using distributive property. So we have 4x plus 8. 11 plus 7x. Combine like terms on the left, 7x plus 8, 11 plus 7x, subtract 7x from both sides, and look what happens. You get 8 equals 11. Well, how can that be? That's not true. That's never true. We took correct steps to get to this point. So when we get something that is not true, never true, our x's are gone, we have to say there is no solution. Sometimes when you're working a problem, you'll have something similar happen. You'll end up with, well, let me just give you a simple example. Suppose you have x plus 1 equals x plus 1. And you subtract x from both sides, and you get 1 equals 1. Well, that is true. That's always true. So the solution can be anything, all real numbers. So sometimes there is no solution, and sometimes absolutely anything works. So you need to be aware of that and be prepared to have both of those situations occur. So now we want to talk about inequalities, section 1.4. The blank of an inequality is a drawing that represents its solution. What is that? It's a graph. So we want to find the graph of these inequalities. We're going to be careful how we do that. For the first problem, x is less than 2, but it can't be equal to 2. So we're going to draw a hollow circle around the 2 to show that the 2 is not included. We're going to shade to the left because we want numbers that are less than 2. Let's draw a big arrow there to show that we keep on going to the left in the negative direction as far as we want. What if x is greater than or equal to 1? This time we want to include the 1. We do that with a solid circle. X has to be greater than 1, so we're going to the right. Now x is between these two values. You want to include the negative 3, make it solid. You do not want to include 0, leave it hollow, and shade in between. So those graphs represent our solutions to the inequalities. Another way to write solutions of inequalities in one variable is to use interval notation. Interval notation uses parentheses and square brackets. You can look in your book on page 114 and 115 to see more information about that. So let's look at these example problems again and write them in interval notation. Now, looking at this graph, we see that you can go as far to the left as you want. Well, if you keep going to the left forever, how can we represent going to the left forever? With the idea of negative infinity. It just means go as far to the left as you want to go. Now, what do? You keep going until you get to the number 2. We do not want to include the 2. We represent that with a parenthesis. We also use a parenthesis wherever we have positive or negative infinity. If you use a square bracket, it means include the endpoint. You can't include negative infinity because you're never going to get there. Because you can never get there, you can't include it, so we always use parentheses with positive and negative infinity. Now in this case, we want to start at 1 and we want to include 1. You show that you're including the 1 with a square bracket. You keep going to the right forever until you get to positive infinity, and you always use parentheses around positive and negative infinity. You want to go from negative 3 to 0. Include the negative 3. Do not include the 0. Square bracket means include it. Parenthesis means do not include it. How about inequalities? We solve inequalities the same way we solve equations. except that we reverse the inequality sign if we multiply or divide both sides of the inequality by a negative number. I want to talk about that for a moment. If we say negative x is greater than 1, let's see what that means. Let's draw a number line. Let's put some values on that number line. Now, this is negative x is greater than 1. The opposite of x is greater than 1. So what if x is negative 4? The opposite of negative 4 is a positive 4. So does that work? Yeah, that works. Negative 3, does that work? Is the opposite of negative 3 greater than 1? The opposite of negative 3 is positive 3, and that is greater than 1. What about negative 2? Is the opposite of negative 2 positive 2? And is positive 2 greater than 1? Yes. What about negative 1? What's the opposite of negative 1? It's a positive 1. Does that work? No. How about 0, 1, 2? No, none of those works because the opposite of 0 is just 0. 0 is not greater than 1. So our solution will be all values to the left of negative 1. So think about what the solution is. The opposite of x is greater than 1. That's the same thing as saying x is less than negative 1. So when you multiply by a negative 1, the original equation, if you multiply this first equation by a negative 1, you get x is less than a negative 1. So whenever we multiply or divide by a negative 1 or a negative value, we have to reverse the direction of the inequality. Let's solve this inequality. 2y minus 9y, combining like terms, minus 7y is greater than 7. Divide both sides by a negative 7. Remember, when you multiply or divide, you reverse the direction of the inequality. So y is less than 1. Here's another inequality. Let's solve it. I'm going to eliminate the smaller of the two x terms. That gives me x plus 1 less than or equal to a negative 3. Let's subtract 1 from both sides. And we get x is less than or equal to negative 4. One more example. Eliminate the parentheses. 6 minus 8m minus 9, that's greater than or equal to 45. Combine like terms. 6 minus 9 is a negative 3 minus 8m greater than or equal to 45. Let's add 3 to both sides. Minus 8m greater than or equal to 48. What happens when we divide by a negative 8? We're dividing by a negative. What does that do? It reverses the direction of the inequality. So we have m is less than or equal to a negative 6. And that's our solution. So we've completed sections 1.1 and 1.4 in chapter 1. That's all for this video. Go to the next video for more information.